Hello to everyone, my name is Lalit Mohan and I welcome you all to Vidhyashila Education. And in today's lecture, we will be discussing all about the basic concepts of circle as per as class 10th syllabus of CBSE. Circle is one of the most common two-dimensional geometrical shape which we can see all around us. From smallest machine to biggest marvel of the world, we can find circle in any form. One of the greatest invention of mankind is wheel, and today's world is quite impossible without the circular shape. Now coming to the definition of the circle. Circle is the collection of all the points in a plane which is 2D shape which are fixed at a distance from a fixed point in a plane. For example, so let's take 2 points, one is O point and one is P point. O point is fixed point in the circle and P moves and P will be moving in such a way that the distance from O will always be fixed. So the shape thus formed will be called a circular shape, and the distance, the constant distance will be the radius of the circle, and the the fixed point will be called the center of the circle. There we can see two definitions. One is of center of the circle and another one is the radius of the circle. The radius will be fixed. The radius will be fixed distance and center will be the fixed point. Now moving forward, let's see the definition of chord. Chord is line segment which touches a circle in 2 points. Chord will be always inside the circle and it will be touching the circle in 2 points. Now let's see the definition of diameter. Diameter will be the largest chord of the circle. There will be no chord larger than the diameter, and diameter will be always twice of the radius. Diameter always will be twice of the radius, and this is very important relationship. Now let's see the definition of secant. What is secant? Secant is a line which intersects the circle in 2 points. Secant, in the figure we can see the green line is secant which intersect circle in 2 points, and this divides the circle in 2 parts. One is 2 segments, one is minor segment and another one is major segment. Now comes the definition of tangent. A tangent is a line outside the circle which touches a circle in a point, and we will be discussing tangent in detail in further slides. Now let's see circumscribed circles. A circle which is outside of any polygon is called circumscribed circle, and the circumscribed circle touches all the vertices of the polygon. A polygon could be of any number, made up of any number of sides. This could be a triangle, a rectangle or any quadrilateral. The circumscribed circle can be drawn by the perpendicular bisectors, and the center will be called circumcenter, and the radius of the circle will be called circumradius. Now let's see the definition of incircle. Incircle will be obtained by the angle bisector, and incircle will be always inside any geometrical shape like triangle and rectangle, and the radius will be called in radius, and the center of that circle will be called in center. One of the most commonly theorem used in this chapter is Pythagoras theorem, and for application of this theorem one angle must be right angle, or the triangle must be right angle, that is one angle must be of 90 degree, and the one angle, suppose this angle is 90 degree, the facing side of this will be called hypotenuse. So here C will be hypotenuse and B will be here perpendicular and A will be here base. So according to this theorem, the square of hypotenuse will always be equal to the sum of the squares of perpendicular and base. So in this way we can simply write this: C square is always equal to A square and A square plus B square. So this is most commonly used theorem in this chapter. Few more things to know about circle is the area of circle is pi r square. This will be used further in future lectures. The perimeter of circle is 2 pi r or pi d. D here is diameter, r is radius of the circle. And now let's discuss about the pi. Pi is simply the ratio of perimeter to its diameter. Pi is irrational number. Pi is non-recurring decimal number which consists of all the permutation and combination of all the numbers in the world. But its approximate value that we take is 3.14 and 22/7 according to our suitability. So now let's dive deep in the concept of tangent. Now the tangent of circle, as previously discussed, the tangent is the line that intersects the circle at only one point. That means the tangent will be drawn from outside the circle and it will touch the circle in only one point. And the word tangent, that comes from Latin word tangere, which means the touch, to touch. And it was introduced by Danish mathematician Thomas Finnecke in 1583. And few facts must be known about tangent. That one is, there is only one tangent at a point of the circle. At a point of circle, suppose this is a point, and from outside the circle only one tangent can be drawn at this point. But on the circle, overall circle, there might be infinite number of the tangent that can be drawn. And the tangent to a circle is a special case of secant when two ends of its point corresponding chord coincide. Coincide means when 2 points of the secant, as we know that secant intersect circle in 2 points. When those 2 points coincide, that means they becomes one, then the secant will be tangent of the circle. The common point of tangent to a circle is called point of contact. That is a very important concept. The point of what is it can be asked, what is point of contact? The contact of circle and tangent is the point of contact. Thus, and another important fact and another very important concept is the tangent is always perpendicular to the radius of the circle. In further slides, we will be deriving this result. Now let's move to the first theorem of this chapter, which states that the tangent at any point of the circle is perpendicular to the radius through the point of contact. Here we have to prove that the angle between radius and the tangent is of 90 degree. So xy is given the tangent here and OP is radius, P is the point of contact. So we have to prove that OP is perpendicular to xy. So we make some construction. We joined O and Q. Q is the point in the tangent xy. Now we joined O and Q, and Q lies in the tangent xy. So the point Q, let's see about that. The point Q will always be lying outside the circle, because xy is a tangent. If this will be lying inside the circle, then xy would have been a secant of the circle. But it is given that the xy is tangent of the circle, so it will be lying outside the circle. So the distance OP will be less than OQ, because OP is radius of the circle. So we can take infinite number of points here in the tangent xy, but no distance will be less than OP, because all the points will lie outside the circle and only one point P will be in the circle, and OP will always be less than all the points that we take in the tangent here. So we can say that OP is the shortest distance of the point OP is the shortest distance of the point O to points of XY. So this can be called, this can also be called the OP is perpendicular to XY, because the shortest distance between 2 points is always the perpendicular distance. And thus we can say that the tangent at any point of the circle is always be perpendicular to the radius, and this is very important result for our question purposes. And by this theorem above, we can also conclude that at any point on the circle there can be only one tangent. So this is one of the this is one important result also. And the perpendicular or the point of contact is can also sometimes be called as normal of the circle. Now let's attempt the first question on the basis of previous theorem. A tangent PQ at a point P of the circle of radius 5 cm meets a line through a center O at a point Q, so that OQ equals to 12 cm and length of PQ is. So we have given the radius of the circle, that is 5 cm, and OQ is given, that is 12 cm. PQ is the tangent that is given, and point P is the point of contact of circle and the tangent. So first we have to label the diagram, and first we have to draw the diagram and then label it properly. So the radius will be OP will be 5 cm, and OQ is given, that is 12 cm. So in this diagram, the triangle QPO will be a right angle triangle, and this angle P will be of 90 degree. So we have to find a base here, third side. So we will apply Pythagoras theorem. So according to Pythagoras theorem, hypotenuse square, which is hypotenuse is OQ is hypotenuse. So hypotenuse square, that is 12 square, equals to QP square, that is base, and we have to find QP, and plus OP square, OP that is 5. So 5 square. So square of 12 is 144, and QP square, and square of 5 is 25. So OP square equals to 144, 25 is adding here, so it will be subtracting when we move this across. So QP square will be and QP will be, here is square, so we have to find out square root of 119. So this will be our final answer. This will be our final answer. Now let's move to the next topic, the tangent from a point on a circle. There can only be drawn two tangents from a point outside the circle. So let's say point P is outside the circle, and only two tangents can be drawn from this point, and these two tangents will always be equal, and the this length PT1 will be called the length of the tangent. And one most important result is that the tangent drawn from a point will always be equal. Now let's move to the second theorem, which states that the lengths of the tangent drawn from an external point to a circle are equal. So we are given a circle and point, and from the point two tangents are drawn, and we have to prove that the tangents are equal. So let's see in the diagram, point P is given and a circle of center O is given, and from point P two tangents PQ and PR are drawn. So we have to prove that PQ is equal to PR. So we must do some construction. We joined OQ and OR, these are the radius of circle, and then we joined PO. In this way we formed two triangles one is PQO, triangle number 1, and triangle number 2 is PRO. So let's see, in these two triangles, PO is common to both the triangle, and OQ and OR are the radius of the circle, so these will be equal, and angle R will always be equal to angle Q, because these are radius and these will be perpendicular to the tangents. So by RHS both the triangle will be congruent. Triangle POQ will be congruent to triangle PRO. So these two triangles are congruent, so PQ will be equal to PR by CPCT, and in this way we have proved that the length of the tangent drawn from external point to the circle are equal. This is one of the most commonly theorem used in this chapter, and this theorem can also be proved by the Pythagoras theorem in both the triangles. As we can see that PO is common, and QP and QO and RO are equal because these are radius of the circle. So let's note them with R. So if you apply Pythagoras theorem in this triangle PQO and in this triangle PRO, we can find that PR will be equal to PQ. The line PO is angle bisector of angle QPR. So angle QPO will always be equal to angle RPO. If this angle is theta, this will also be theta. So this is also an important result. Now let's move to the question number 2. In this question we have to prove that two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So concentric circles are those circles which have same center. These are called concentric circles. So we have to prove that two concentric circles, as we can see by this diagram, that two concentric circles C1 and C2 are there, and the AB line is chord for the C1 circle, the larger circle, and the tangent for C2 circle, the smaller circle. So we have to prove that AP is equals to PB. So we must do some construction here. We joined AO and OB. Now let's see in triangle AOP and triangle BOP. We have to prove that AP equals to PB. We have to prove that. So let's see in the triangle AOP and triangle BOP. So angle AO will always be equal to BO. AO equals to BO because radius of these are radius of larger circle, and angle P is equals to angle P because these are perpendicular, and third one OP is equals to OP common. So by RHS triangle AOP is congruent to triangle BOP. So AP equals to PB, hence proved. This is quite simple question. First, these are two radius of the larger circle, and this is common, and this is perpendicular to the AB. OP is perpendicular to AB, so by RHS, we can say that both the triangles are congruent, and then AP equals to PB. So let's move to next question. In this diagram, we have to find angle PTQ. Angle PTQ, this angle we have to find, and T is the point. P and Q are the point of contact. PT and QT are the tangents. These are tangents, and then we have to find angle PTQ, and this angle is given 110. This is radius, OP is radius, so this angle P will be 90 degree, and this is radius, OQ is radius, so this angle will be 90 degree, and this is a quadrilateral, so O P T Q is a quadrilateral. So angle P plus angle O plus angle Q plus angle T is PTQ. Angle T is the sum of the internal angle of quadrilateral is 360 degree. So angle P is 90 degree, plus angle O is 110, and angle Q is 90 degree, and we have to find angle T. This is 360 degree. So this will be 290. This is 90 plus 110, 10. 90 plus 110 is 200. 200 plus 90, 290. So 290. 290 plus T equals to 360. So angle T will be 360 minus 290, that is 70 degree. So angle T, which is angle PTQ. So angle PTQ equals to 70 degree. So that's all for today. We will be discussing more questions of circle in next lecture, and please like and share this video and subscribe to my channel. This is Lalit Mohan with Vidhyashila Education, and class dismissed.